Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is lesson 1.4, Slope and Linear Functions. Let's get right to it. Today we're going to talk about defining slope as a rate of change. We're going to calculate slope. We're going to write linear functions in two variables, and then we're going to use slope to identify parallel and perpendicular lines. And then we are going to use some equations to solve problems. So first, a few definitions. Slope is a numerical ratio that represents the change of y of a line divided by the change in x for the same line. And so a lot of times you'll see slope written as the lowercase m, and the colloquial term of rise over run, or the change in y over the change in x, which is calculated by taking two y values and subtracting them, and two x values in the same order and subtracting them as well. We have three equations that are going to be pertinent to this discussion. The slope-intercept form of a line, that's important because it's easy to put in your graphing calculator. The point-slope form of a line is easy because, or actually important, because this is what we're going to use when we're writing linear equations or linear functions. And the general form, ax plus by equal to c, that you'll see often in certain standardized tests. And we also will use this later on, this form later on, the general form, when we're talking about matrices as well. But that's for another time. Special cases, here, there's a vertical line, it's x equals some constant, and a horizontal line, y equals to b. And again, if you think about a horizontal line, and you'll see it here in a moment, but if I go y equals 0x plus 3, well, if the slope is 0, that means it's, and you know what I'm saying, m equal to 0. When we think about it in terms of the, let's go back one step there. It's too far. Get rid of that m as well. Not getting rid of it. All right. If m is equal to 0, and we're talking about it in context of rise over run, it is rising 0 over, it doesn't matter how far it runs. So if it doesn't rise at all, this, and again, that'll cancel out because 0 times x is always 0. Y equaling to 3 is going to be a horizontal line right at 3 on the y-axis. All right. Some special notes that we need to take into consideration, especially after talking about our goals for the day. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of each other. And so if we saw two lines like this, one was y equals 1/2 x plus 5, and y equals 1, come on, y equals to 1/2 x minus 2. Those two lines, it's not a very good 2. These two lines are parallel. And if I wanted to do a negative reciprocal, so if I wanted to have perpendicular, since this was already negative 1/2, a negative reciprocal, you take that fraction, you flip it, that'll make it 2, but we also have to make it negative, so it'll be negative 2x plus 3. These two lines right here are perpendicular. And that's not a very good U. Let's see if I can fix, no, that doesn't help at all. Perpendicular, perpendicular. All right, find the slope of a line that passes through the 2 points, 2, 4, and 4, negative 4. So here's what I'm going to do, because I'm going to use this equation that we learned in this past slide here. So I'm going to assign this first point x1 comma y1, and I'm going to assign this second point x2 comma y2. And we'll use the slope m equaling to y2 minus y1 all over x2 minus x1. And I'm just going to plug in. So my y2 is negative 4, and my y1 is positive 4, so subtract 4 from that. And then x2 is 4, and x1 is 2. So 4 minus negative 4 is negative 8. 4 minus 2 is 2, Negative 8 divided by 2 is negative 4. That is the slope of that particular line. And I think it's going to make sense if we think about it in terms of a simple graph here. If I go 1, 2, 3, 4 along the x-axis, 4, negative 4, 1, 2, 3, 4 would be, ooh, what happened there? This point right here, and 2, positive 4, 1, 2, 3, 4, right there. If I talk about the line that connects those 2 points, clearly that thing is going to have a fairly steep and negative slope. All right, next it says use the point and the slope to find 3 additional points through which this line passes. All right, so if I think about it this way, if I start with a graph, and I'm going to use an actual graph this time, maybe it'll be a little bit nicer to look at. If I do it that way, I want to find 3 additional points. So 3, negative 2 is right here. 3, negative 2, let's get the right tool there. 3, negative 2 is right there. And this thing has a slope of 1. And remember, this is the rise over the run. So it's going to rise 1 and it's going to run 2. So 1 additional point would be, let's see here, 5, negative 1. And if I wanted to do another one, I could go up 1, right 1, 2. Well, that would put it at 7. So I would be at 7, 0. But I can also go backwards. So I can go back 1, 2, and down 1. So back 1, 2, down 1. That would be 1, negative 3. So there are 3 additional points. Those aren't the only ones, but those are 3 points through which that point passes. Write the slope equation, intercept form of the line. Use the given point to write A, the line parallel to the given line through the point, and B, perpendicular to the line through the given point. All right, so the first thing we want to do is whoa, that went kind of crazy. First thing we want to do there is we want to put this into y equals mx plus b form. And so what I'm going to do is I'm going to solve this for y. And so if I'm solving for y, I think I want to move this out of here for now. And we'll get back to that. And so I'm going to subtract 3x from both sides. And that'll give me 2y equals negative 3x plus 8. And then I'm going to divide by 2. And so that'll give me y equals negative 3 over 2x. And then 8 divided by 2 is going to be 4. All right. So this is my, write the slope intercept form. So this right here is my slope intercept form. And so I want to write a line parallel to the given line through the point. So if I think about this thing, it's got a negative slope and goes through 4. So just real quick here, I got 4 there, and I've got this line that's negative slope. Oops, that's not very good. So it goes through this. And so what they want me to do is they want me to find an equation of a line that's parallel to this line that goes through 3, 5. So if I go 1, 2, 3, and I go through 5, I have at that point there, they want me to come up with the equation of that particular line. And then they want me to do one that's perpendicular. So they also want me to come up with the equation for that line. So to do that, I'm going to go back up to here and I'm going to use this point slope form of the line. And that point slope form is y minus y1 equaling to m, oh, come on, m times x minus x1. Now in this particular case, this is my x1, this is my y1, and then the slope is the corresponding slope to that line. Now for the first one, for the red line here, what I want to do is I want to have the same slope. So it's going to have a slope of -3/2, and we're going to use the 0.35 in here. So I'm going to go y minus 5, that's my y1, equaling to -3/2 times x minus 5. No, sorry, made a mistake there. Let's fix that. Remember, it's x1, so x minus 3. All right, so the first thing I want to do here is I want to distribute. All right, so I've got my y minus 5 equaling to, well, it's going to be -3/2x. And then when I multiply negative times a negative, I'm going to get positive. 3/2 times 3 is going to be 9/2. Now I'm going to add 5, but there are 5/10. There are 5, excuse me, start over. I want to add 5 to 9/2. Well, they don't have a common denominator, so I got to come up with a how many halves are in 5? Well, there are 10 halves in 5. When I add it to 9 halves, I'll get y equals -3/2 x plus my 10 halves and my 9 halves is 19 halves. And we'll call it there. There's my parallel line. And then we want to do the same thing, except we want to use we want to find a perpendicular line. So we're going to start with a y minus y1 again, equaling to m times x minus x1. And what we're going to do is we're going to use the same x1, y1. So we'll have y minus 5 equaling to x minus 3 here, like we did in the last one. But we want to get the perpendicular slope, so we need the negative reciprocal of that. So the reciprocal of 3/2 is going to be 2/3. And when we think about this other value here, because it's negative, we're going to make it negative again. So negative and a negative is a positive, so that we're going to stick with that. So again, I want to distribute. So I'm going to go y minus 5 equals, when I distribute, I'll go 2/3 times x is 2/3 x, and then 2/3 times 3 is going to be -6/3. Now again, we're going to add here, but this time instead of having to add to halves, we're going to be adding to thirds. And so if there were 10 halves in 5, there are 15 thirds in 5. So I'm going to go y equals, I need my 2/3 x, and when I add 15 thirds to -6 thirds, I'm going to have a positive 9 thirds. And that right there is going to be my perpendicular line. And that's all I got for today, folks. So the Marvel fun fact of the day, Avengers Endgame boasts 19 actors who have either been nominated for or won the Academy Award. That's quite a bit. That's all I got for today, folks. Have a good one. Goodbye.